All right, we are in Unit 2, Lesson 7. We're in Chapter 5, Section 8 of the textbook, and we're going to be talking about the rational zero theorem. We've got one mathematical practice that we're going to focus on in this lesson, and that is practice number 8, to look for and express regularity in repeated reasoning. So in the past, in previous lessons, we have found zeros for quadratic functions of the form ax squared plus bx plus c. And in this lesson, what we're going to do is identify possible rational zeros of a polynomial function and then find all of the rational zeros of a polynomial function. So we've got this thing called the rational zero theorem. And basically what this says is that if you have a polynomial with integral coefficients, then every rational zero of the polynomial is of the form p over q. And p is a factor of the constant term. P is the last term in the polynomial, and q is the factor of the leading coefficient. So when you have a polynomial such as this one right here, you're going to look at the number -40 and you're going to look at the number 6. And what we're going to do essentially is write down all the different numbers that make up factors of -40 and all the different numbers that make up factors of 6 and write them as quotients of this factors of -40 over factors of 6, all the different possible combinations. And then we're going to try some of them to see which ones are zeros. And trying them means that we'll be doing synthetic division. So in our first example, all we're going to do here is identify all the different possibilities that might be the zeros of a function. So we've got the function 3x to the fourth minus x to the third plus 4. So first we need to find our q and our p. So p is 4, so we need all the different factors of 4, and q is 3, so we need all the factors of 3. So the factors of p, of the 4 value, you could have plus or minus 1, you could have plus or minus 2, you could have plus or minus 4, because 1 times 4 would give you 4, and 2 times 2 would give you 4, and then -1, -4, and -2 times -2. For 3, you would just have 3 times 1, so you'd have plus 3 and plus 1, and -1 and -3. So what we're going to do is we're going to take these combinations and write them as fractions. So when we do that, if we take 1 over 1, we get the 1. When we take 1 over 3, we get 1/3. 2 over 1, 2. 2 over 3, 2/3. 4 over 1, we get 4. 4 over 3, we get 4/3. And each time you're going to say plus or minus one of these numbers. And that's really all there is to it when you're just listing the different possibilities that might be answers. Okay, part B, we're going to try another one. This time we have x to the fourth plus 7x cubed minus 15. So this time our p-value is -15, and our q-value is 1. There's just an imaginary 1 out here. So all we're going to be able to do is take the factors of 15 and divide it by 1 or -1. So our factors of 15, we could have 1 times 15, we could have 3 times 5. So we have plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. All right, some check your progress problems. Part A, you've got 2x cubed plus x plus 6. Pause the video when you have your answer, go on to the next slide. Okay, our answer this time is C. Make sure you do all the factors of 6 divided by all the different factors of 2. For part B, x cubed plus 3x plus 24. Pause the video when you have your answer, go on to the next slide. Okay, our answer this time is choice B. Because we just have 1 here, it's just going to be all the different factors of 24. All right, in example 2, we're looking at a real-world problem. It says the volume of a rectangular solid is 1,120 cubic feet. The width is 2 feet less than the height, and the length is 4 more feet than the height. Find the dimensions of the solid. So again, this time it's a good idea to sketch a picture of what this rectangular solid is going to look like. Here we have our rectangular solid. Notice that they put the width in terms of the height and they put the length in terms of the height. So the height is going to be your plane variable, that's just x. The width is 2 feet less than that, so x minus 2. And the length is 4 feet more than that, so x plus 4. So we've got all of our dimensions. What we're going to need to do next is multiply them all out. And when we multiply all those 3 terms together, we're going to get x cubed plus 2x minus 8x equals the volume that they gave us, and then we need to bring that volume to the left side so that all of our terms are on the same side. Then we're going to find our p and our q. Our p is this negative 1120, and our q is 1. So we're just doing all the different factors of 1120 over 1. And that might take you a little bit of work to find all the factors, but they've written them out for you. Notice, obviously, there are a lot. If you have a real-world problem, you might have more factors than if you just have a plain computational problem, just because you're likely to get larger numbers in real life. So what they've said is by Descartes' rule of signs, and that's the rule that we did in the previous lesson, they found that there's only one positive real root, so they tested some different possibilities. If we go back and look at this polynomial again, what they're going to do on this next slide is they took the coefficients 1, 2, negative 8, and negative 1120 and did synthetic division, and they just tried positive numbers until they got to the answer. And you can see from the table that they put on here, they tried the number 1 and they got a remainder of negative 1125. So they knew 1 wasn't the factor. Then they tried 2 and they got negative 1120. And they didn't do all the different, they didn't show all the work for all the other numbers, but basically what they're saying is that they tried 1, 2, 3, all the way down to 10, and it took them until 10 to get a remainder of 0. And so that means that the answer for the dimension, the side x, is 10. So that means the height was 10, the width was 10 minus 2, so 8, and the length was 10 plus 4, so 14. And if you do 10 times 8 times 14, you should get that answer of 1120. All right, here's another real world problem. Basically the same concept. Um, work this out when you have your answer. Go on to the next slide. Okay, the answer this time is B. If you were doing this like on a standardized test and they had multiple choice right here, I think the smartest thing to do would be just to multiply the different dimensions they give you together and see which one gives you the desired value of 100. 5 times 10 times 2 gives you 100. I don't believe any of these other ones will give you 100. But if this is like a test thing that you're doing in class, for your teacher, then you definitely want to make sure that you follow the process that's been demonstrated in the example. Okay, for example 3, we're going to find all the different zeros. And we have a fourth degree polynomial, which means there's going to be 4 zeros. They might all be real, some of them might be imaginary, but we're going to try to find all 4 of them. We've got x to the fourth plus x to the third minus 19x squared plus 11x plus 30. So the first thing we're going to do, so they've actually gone ahead and they did Descartes' rule of signs. They checked all the sign changes, and they found there's 2 sign changes for f of x, and then they did negative x also. And when they did negative x, they also got 2 sign changes. So they know that there's either 2 or 0 positives and 2 or 0 negatives. Then we took p, which is 30, and q, which is 1, and wrote down all the different possible combinations that might be zeros. So really this is just all the different factors of 30. So we have 1, 2, 3, 5, 6, 10, 15, and 30. And then we're just going to make a table and test some values. We're testing them by doing synthetic division. So we tried the number 1. We did that. We got a remainder of 24. So 1 was not the answer. Then we tried 2. We did 2. Oh, we got 2 as an answer because the remainder is 0. So because of that, we know that one of our answers is 2, and then this is called the depressed polynomial, but it's basically when you take out, it's the answer from your synthetic division. So this up here, if this was 4th power, we're now at 3rd power. So x to the 3rd plus 3x squared minus 13x minus 15. So we're going to take this next polynomial that we've just created, the 3rd degree, and we're going to try another factor from our p and q list, p over q. So this time we tried 3. We've already tried 1, we've already tried 2. So now we're trying 3. We try 3, and oh look, we get another remainder of 0, so we know 3 is another factor. That means we're left now with a 2nd degree polynomial, x squared plus 6x plus 5. And this is something that you can factor using methods from Unit 1. And obviously this just factors into x plus 5 times x plus 1. And so the answers for that are -5 and -1. So we found 2 more answers. Our first answer was 2, our second answer was 3, and now we've got the last 2 answers. So our 4 answers, again, -5, -1, +2, and +3. Okay, try the same process now on the check your progress problem. Notice again it's a 4th degree, so obviously here it's either going to be A or D. But go through and try the process for finding the rational roots, the possibilities for P and Q, and do your synthetic division. When you have your answer, go on to the next slide. All right, the answer for this one is D. The answers are -5, -3, 1, and 3. And that's the end of lesson 7.